Yes, ma'am.
Hello everyone. So today we are learning the subject of your circuit theory. In that we'll see the chapter of your the steady state and the transient response. Okay. So in this part we will see here the introductory part which is related to the steady state. So here in the steady state, first of all we will see go through at the beginning, that is nothing but your the DC circuit. That is important which circuitry we are going to use, whether it's a AC circuit or whether it's a DC circuit. That is too important. Okay. And because we here the excitation is important, how we are giving the excitation, which form of excitation, which is my source, that is important. That's why while you are talking about the either the steady state or the transient, you should take care which circuitry is there, whether it's AC or whether it's a DC circuitry is there. So that is too important. Fine. So here whenever the current which is flowing through the circuitry and that current is not at all going to be changed with respect to the time period. Okay. So that time you can say that circuitry is nothing but the steady state, and that is possible. Okay. But practically you will be able to observe all these things whenever the circuitry is in the short circuited time. So in the steady state you can say the charges or the current which is flowing through the any part or any point in the circuitry, that should be equals to what you can say the current which is flowing through that circuitry. Okay. So in this way, in short, you can say current should not be changed with respect to the time period. So now the question will arises as we mentioned in the chapter, that is nothing but the steady state as well as the transient response. Both the things we have mentioned in the chapter, that is included, both are simultaneous. That is the steady state as well as your the transient response. So here we should take care what is the difference between the steady state as well as the transient response. What is the difference? So steady state is the state that is established after a certain time in your the system. The transient state is basically between the beginning of the event and the steady state. In short, see here, we remember what is going on here. Steady state is nothing but at a certain time period in the system. Okay. And at the beginning of the system, whenever the system is going to be start, whenever the excitation is given and whenever you are going to calculate the parameters at that time, that will be the transient. And before that, that is nothing but the steady state. So in short, you can say the transient analysis is not only the valid for the temperature, for the various parameters which are included, not only for the what we can say electrically, but mechanical terms will be included in that. So in short, you can say the transient response is basically the beginning part. Okay. That is nothing but at the beginning part. What is the transient responses? That is important. In the electrical engineering and the mechanical engineering, the transient responses is the response of the system to change from the equilibrium or a steady state. Keep your mind. The equilibrium means the constant term, means the steady state. The constant term and the steady state and the equilibrium. Later on, the condition which is changing onwards from the steady, yani from the constant towards the changing. Okay. Till the constant term, that is nothing but the steady state. If the things are going to be changed, that is nothing but the transient state, or you can say the transient response. If nothing is going to be changed, okay, with respect to the time period, okay, if nothing is going to be changed, which is constant, which is equilibrium, which is steady state, so that responses are the steady state response. But the things are changing. Things means what? Maybe the current, most probably the currents, the voltages with respect to time period, if they are changing, definitely that responses are nothing but your the transient response. Okay. So in any field, just like with the electrical, mechanical, doesn't matter which is the field, but the thing is that whether they are changing from the constant to the variable or the varying state. Okay. Constant is nothing but the steady responses, and the variation from where the changes are going to be happen, that responses are nothing but the transient response. So here the transient responses is not necessarily tied to be a abrupt event, but at any event that should be affecting the equilibrium of the system. So onwards, the variations after the steady state is nothing but your the transient responses. So here the question again will arise, why we are studying the transient response? What is the need of this transient? Steady state we understood. Okay, we are not doing anything. So the current is not changing with respect to the time period, and circuitry is there, no change at all. Constant steady position is there. Okay, that we can understand. But why the transient responses are happening and they are coming up. Okay, so why we are interested in the transient response. So here we can understand that the output transient responses is very important, because at ultimate, at the end, we are interested what should be my output. Ultimate, what we are interested, whatever we are applying the component to the circuitry, whatever we are giving the sources, whatever we are keeping the load, whatever the things are going, ultimate the thing is that we are doing for the outcomes, we are doing for the output, what should be my output of my network. Okay, so the thing is that here the output transient response is too important. In short, the characteristics of your the output voltages, if you're talking about in terms of the voltage, if you're talking about in terms of the current, if you're talking about in terms of the power. So in short, you can say the output is important. Okay, so for learning that output, for the what you can say the change in that output, so we the which is a very important, this transient response plays a very important role for the point of your the output. Okay, so output in terms of the voltage, current, and the power that we are going to measure at the end side. Okay, so this characteristics is too important, we know very well, which is related to the stability of the output voltage with respect to the load current. Because if V is directly proportional to I, that we are aware. If the load is changing, the current which is flowing through the load is changing, definitely my voltage will be changed. Okay, so here from the stability condition to the variable condition, from the constant state to the change state. Okay, so ultimate at the output side, my current is till the period of no change in the current with respect to time period, steady state, no doubt at all. But if my current is changing with respect to the time period, and I am measuring that part at the output side, definitely that output part will be important to me. Okay, so here the current which is flowing at the load and I'm measuring in terms of the voltage. So definitely for this point of view, we are interested to learn, study about the transient responses. So you, in short, you can say this is a need or the requirement of your the transient response at the output side. Similarly, how can we measure the basic formula related to the transient time is nothing but your the tau, which is denoted by the tau. Tau is nothing but the transient response or the transient time, which is denoted by the tau, and that is nothing but your the combination of your the RC, that is nothing but the resistor as well as the capacitor, and that we are going to measure in the seconds. So R is the resistor and C is the capacitor value, which is measured in the ohm and the farad both. So if we are thinking about the transient, means we are interested in the time. If we are interested in the time, means the circuitry should be the combination of R and the C. Now the next thing is that how we can analyze, okay, on which particular circuit we are going to be analyzed. So that thing is the possibility of your the two major analysis, that is nothing but your the AC as well as the DC. Already we have seen in the previous chapter, chapter number 1, that is nothing but you are the in the theorems, that is the AC analysis as well as the DC analysis. And already we have observed in the AC analysis is that there will be the sinusoidal change, sinusoidal signals is there that we are going to apply, and we were interested in the impedances, just like you are the examples, that is equals to R plus G of X. While you are going to learn about the DC, there were no sinusoidal waveform was there, and there was no impedance, that is nothing but the Z. Directly we were measuring the voltage, current, and the power. So see here the difference between the AC and the DC analysis. Similarly, while you are going to study the transient, so definitely RLC circuit will be there. If RLC circuit is there and switches are there, and we are interested to measure the with respect to the time period, and my excitation will be the sinusoidal. So that time definitely I am analyzing my AC. Okay, if there is a battery, okay, cell is there, and what we can say, there is no variation in the component and at the switches, so definitely that is nothing but the DC form. So in short, two analysis part, that is nothing but the AC as well as the DC. So here, while we are studying the AC and the DC transient analysis, so we should aware from the basics what is mean by the AC analysis, what is mean by the DC analysis. So in short, you can say the transient analysis gives the time domain waveform which are plot over the voltage or your the current with respect to the time period. Okay, see here the difference. Transient time, related to the time domain, because we know very well while you are going to draw the any kind of waveform, so either that will be the time domain or that will be the frequency domain, because the broadly classification of your the waveform with respect to which things you are going to be calculate, so that will be either in terms of the time domain or in terms of the frequency domain. If that is in the time domain, so that is nothing but we are studying about the transient analysis. Okay, so here with respect to time period, two major parameters are there, we know very well. One is known as your the current, and other is known as your the voltage. And either the current or the voltage with respect to time is either the V with the T or the I with the T, that you can measure. Okay, that you can measure. And that analysis by measuring what will be my excitation, what how much amount of a current, that is nothing but a basic example. V of t, V in bracket of t, that is nothing but I am interested in the voltage with respect to time period t. So V of t, I of t, that is nothing but current which is flowing through the circuitry with respect to the time period. So notation will change. See here, I is flowing in a simple manner, you can be in the DC form. Okay, but is changing in the transient response in the AC, that is nothing I of t, V of t. Okay, similarly in the AC analysis, which gives the voltage and the current versus the frequency in the linear form version of the circuitry. Okay, here will be the stepped voltage and the current. See here, the linear and the step, the changes is nothing but stepped form means zeros, and the one we are talking about the digitally DC form. Okay, there will be here will AC is every time the sinusoidal waveform will be there, and the voltage and the current they are changing with respect to the time period. Okay, and we know very well while the sinusoidal waveform will be there at particular instant, every time in the sinusoidal waveform, if you observe the frequency is changing 0 to pi, pi to 2 pi means what? 0 to pi, pi to 2 pi means what? Omega is equals to 2 pi f. Okay, and f is equals to omega divided by 2 pi. So in short, you can say t is equals to 1 by f or f is equals to 1 by t. Okay, if you are talking about the t, okay, ultimately you indirectly you are talking about the frequency. If you're talking about the frequency means indirectly you are talking about the time period. Getting my point? So here the frequency, the if we are interested in, with respect to the frequency term, so this will be the analysis. Here will be the zeros and ones, that is nothing but the step voltage and the current, that is nothing but AC analysis form. No doubt we are measuring the two major parameters, the voltage as well as the current. The next is nothing but your the step and the natural responses. So what is mean by the step and what is mean by the natural response? So here the natural responses is to the zero input response. Zero input response where only initial condition generates the system responses. See here, where only the initial conditions at the beginning, at the initial point, at the input side, if nothing is there means we are treating as a reference zero. We know, we are aware from that at the beginning. If we are not going to measure anything, but if you want to observe, you can say at the if nothing is we are going to measure and nothing's load is there to get that response, so definitely my input will be at a zero input response. Okay, at the initial conditions where the system is gives the natural responses, that is in the form of a zeros. Transient response referred to be the system response to a time domain input signals such as the impulse or the steps. Whenever we are going to measure with respect to the time period in the entirely system, that is nothing but the excitation, that is nothing but the component which is connected, that is nothing but the load connected, and we are measuring all these things, and the signal is passing, the excitation is going on, and with respect to the time period, then that time, that responses is nothing but the step or the impulse responses. Similar to that, the transient response parameter, which things are there that we need to measure while we are talking about the transient response parameter. So the transient response characteristics while we are studying the control system, we might be have studied the what we can say FCS subject also, that is nothing but the feedback control system. So if system is there, if the input and the output port is there, and we are interested to measure the things from the input output, all these things, so the controlling part, that is a feedback loop, closed loop, open loop, that you are aware. So similarly, if control system is the system which can be controlled, the parameter which can be controlled either at the input side or at the output side. Many times it's happened. The input will be the fixed, the output will be the variable by changing the value. Similar to that, the input, if you are going to change every time, then definitely the output will be the change, like vice versa in all cases. So in that particular cases, when the transient responses, if you are going to measure and if you are to observe the characteristics at that particular system, so definitely we measure the few things. Which are that few things we are interested to measure? The few things are nothing but the delay time, that is denoted by TD, the rise time, that is nothing but the TR, and the peak time, that is nothing but the TP. These are the major broad, what we can say, the parameters of your the transient response. How my signal is going to delay, even though my circuitry is on, even though my switch is closed, even though current is started to flow, okay, and in the what we can say, the component or the passive components are present, still the time taken by that circuitry, so that is nothing but the delay time, that is denoted by TD. Okay, the rise time, okay, once it started, the circuitry once started, and from the what we can say, the initial or the rest or the steady state condition, now it started gradually, okay, gradually it started, okay, and the current is gradually changing with respect to the time period and flowing in the all the components which are present, either the R, L, and C, whatever it is. So definitely that the time which is rising from the gradually from the zero to some up to the some value, so that time is nothing but the rising time and denoted by the TR. The peak time at a particular point, we have I will share you one of the example of your the what we can say, resonance circuitry, and in that we have observed the voltage and the current versus the frequency or the time period. So in that you have observed the peak value, before peak value 70%, that is nothing but 0.707 or the 70.7%. From that we were interested to get the constant or the fixed value, but one was the at the top there was the peak curve, okay, so that is nothing but the peak time denoted by TP. So in this way we can calculate the three time period or delay time, rise time, and the peak time. Later on it will be the decrease in that form, that is nothing but the decrease time. Okay, so that we are not interested, we are interested how much time taken by the circuitry to be turned on to the to set up for that, and later on how much time required for the rising, okay, then the peak, how much time it reaches to the peak value, that we are interested. So now we know in the circuitry, finally in the circuitry, the responses which we are observing in the circuitry, in that we are observing the responses is nothing but your the transient response is the one case, another is nothing but the steady state response. So if the output of your any electrical circuit, the input varies with respect to the time period, is the time response, and there are two type of a time response. One is a transient response, you can say, and other is nothing but the steady response. Steady response, there is no changes at all, even though circuitry is on, even though we are interested to measure the output, but there is no changes as such with respect to time period. Once the changes will occur, once the changes is going on, and once we are interested to measure that the changes is nothing but the transient. Okay, now come to the next is nothing but transient response. We know very well we are observing all these things with the passive elements or the passive network or the passive components, that is nothing but R, what we can say, R and C. So here for the R we know very well, that is in phase we are considering. Okay, the change is nothing but because the measuring element, storing elements are nothing but the L and C. Okay, so the responses we can observe easily from either in the L or in the C. Okay, either in the L or in the C. So see here the transient response in the inductor, what will be the change we will see here. If we are going to assume the switch action takes place at a particular time, the time is nothing but the zero. Okay, the inductor current, okay, inductor current is nothing but the current which is flowing through the inductor IL, small I, and apostrophe s of L, IL, does not change instantaneously. when the switch action takes place. Okay. Similarly, the value of inductor current just after switching the action will be the same as that of the just before the switching action. Here the meaning is very important meaning is here. When the t is equals to either you can say the first t is small t is equals to 0 is the one case. Small t is equals to 0 minus is the one case. Small t is equals to 0 plus is the other case. Means at instant before 0 will be the 0 minus, at a particular instant is a 0, and gradually if increasing the 0 plus. We remember starting is a 0 minus, middle is the 0, and later on 0 plus. Means this at the 0, that is a particular instant, before is nothing but the initial stage, and onwards is nothing but the what you can say the measuring part, which is a changing part. Okay, so mathematically while you are going to represent how much amount of a current which is flowing through the inductor, that is possible. How it is possible? IL is equals to 0 plus and IL is equals to 0 minus, because at a particular t is equals to 0, nothing is going to be happen. Only for just sake of understanding, we are trying to mention the t is equals to 0. But we know very well that before 0 is one case and after 0 is one case. Before 0, you may say your switch is open. Okay. And at a 0, just initially you just put that switch at the closed moment. Okay, you are closing that switch, and later on when the t is equals to 0 plus means your switch is fully closed and the current is started, and the current is starting to flow, and you can now able to measure the rest of the parameters. So in short, you can say three things are important: 0, 0 minus first, middle is a 0, second is a 0 plus. Likewise, you can measure the IL value, that is current which is flowing through the inductor. Similarly, how much amount of a current which is flowing through the capacitor is also important. But while we are learning the fundamentals, the storing elements, we know very well L and C. So always the current which is flowing through the inductor, we are interested. Similar to that, for the storing element of a capacitor, we are not interested in the current, we are interested in the capacitor, the voltage across the two plates, because we are treating that plates are nothing but the two parallel plates, and that acts as a dielectric. Okay, so we are interested the potential across that is the plus and the minus battery symbolic representation. So we are interested voltage across that plate. So always be remember the capacitor, we are interested to measure the voltage. So that capacitor value, the voltage across that particular capacitor is nothing but the VC. So VC will be the 0 plus and VC will be the 0 minus. That is nothing but the before and after case. At instant is nothing but the 0 case. And before instant is a 0 minus and after is nothing but the 0 plus. So the capacitor voltage, it does not change instantaneously, similar to the inductor current when the switching action takes place. This means that the value of the voltages is just after switching action will be same as just. Obviously, if nothing is going on, so previous and the what we can say the before and the after case will be the equals at the beginning. Okay, just 0 minus will be treated as a 0 plus. 0 minus will be treated is equals to 0 plus, or 0 plus is equals to 0 minus at a particular instant. Getting? At a particular instant, that is 0 condition, your 0 plus will be equals to 0 minus. Now, this was the case in the transit. Now come to the point, that is a steady state in inductor behavior and steady state capacitor behavior. If the independent sources is connected to the circuitry, what we are saying here, if the independent sources are connected to the electrical circuit of the network, one or more inductors and the resistors for a long time, they can be connected to the circuitry. Okay, that is said to be a, you can say that is a steady state. Therefore, the energy stored in the inductor of electric circuitry is the maximum and the constant. Two things are important. RL circuitry is mentioned here. Here, what they are saying, how I can get my steady state condition. Okay, how I can get my steady state condition in the inductor, because R will be treated as a 0 in that phase, but for the L, the current which is flowing through the inductor, that is nothing but the L. So in this L, while I am a study about the steady state, that is nothing but the initial condition. So definitely when the current is starting to flow, that current will be reaches to the maximum, and that will be the constant. All of you pay attention. I am giving you one of the best example, daily routine example. All of you just pay the attention here. I'm giving you daily routine real time application or the example. Okay, how we can understand which is my steady state condition and which is my transient state. Okay, or you can say steady state response or the transient response. See here, all of you, this is the example of your the bathroom. In the bathroom, we know very well daily we open the tab, okay, water tab, and the bucket is there at the bottom of your the tab, right? Am I right? So what you will do, you will turn on the tab. That tab turning on and off is nothing but just like you were the switch. That tab turning on and off is just it behaves, it acts as a switch. Okay, so let it be that switching part. We are interested here the transient and steady state. I'm interested here the word transient as well as the steady state. See here, when the tab is on, the water is start to flow, and that water is flowing in the bottom. That is nothing in that bucket. Fine, everyone fine. Now gradually that the tab is on, water is flowing. Getting, tab is on, water is flowing, and gradually the water is increasing up to the this point. Okay, one time will happen, the bucket will full. See here, the bucket will full. Later on, what will be the case? The water will fall down, okay, from the bucket. The rate at which the fall down occurring of that water will be equals to the rate at which the water which is coming from the what is the tap will be the equals. So once it will be constant, that is there is no change. So the amount the quantity of the water in the bucket which is full now, later on the responses will be equal, steady state. Okay, previously it was changing, or later on also it will be changed, but they are equal. How they are equal? Even the water is falling, even the water is falling from the tap to the bucket, and the bucket to again the bottom, okay, on the floor you can say. So that rate will be equals. Okay, so in short, gradually they are changing. Then one condition will happen, that is a state condition. Okay, steady state. Bucket is full now, there is no as such changes in the bucket. The bucket is full with the water. Okay, so this is a very good example. Similarly, what will be the effect of the inductor here? So here we are interested to find out the energy. You can say the energy amount of energy stored in the inductor, that is nothing but the WL is equals to L LIL square. L IL square. This L is a what you can say apostrophes of L. Be remember, this is the apostrophes of L. So WL is equals to, WL is nothing but the energy stored in the inductor is equals to L dot IL square. Okay, that is the inductor into the current which is flowing through the inductor. Here will be the inductor value. Here will be the amount of a current which is flowing through the inductor will be the twice. Okay, the product of the inductor value as well as the current which is flowing in the inductor twice is nothing but the energy stored in the inductor. So in short, you can say in this way you can get the maximum energy stored in the inductor, and that is a constant value. Therefore, the inductor is acts as a constant current source in the steady state. The inductor acts as a constant current source in the steady state. If we are going to measure the voltage, what will be the change here? So VL is nothing but voltage drop across the inductor is equals to L into DIL. Okay, L into DI small l, apostrophes of L. So that is nothing but L is the inductor, DI by dt. DI by dt is nothing but you are the current